Hey guys, here's the spiral review for spiral 17. This is entirely on logarithms, so we're going to talk about each of these sections as we go through this. First up, we got some log basics. You got to be able to do some converting. You got to be able to do some evaluating. I'm going to show you the work that you need in order to make sense of these problems and get credit for the answers. Okay, log base 3 of 1 over 81. First thing I'd like to do is to set this up as an exponential. And I might recognize that 3 to the 4th is 81. 3 to the negative 4th is 1 over 81. So therefore the answer here is negative 4. For number 2, we're looking at 6 to the x equals negative 36. There is no number that would make this true, so this is an undefined value. For number 3, we're looking at 2 to the x, or 2 to the e, is 1 over 64. Okay, well I know that 2 to the 6 is 64. That means that 2 to the negative 6 is 1 over 64. The answer here is negative 6. And finally, we're looking at log base 216 of 6. I'm going to write that as 216 to the x is equal to 6. I don't know off the top of my head what's going to make this true, but I could rewrite this as 6 to the 3rd to the x is equal to 6. In other words, 6 to the 3x is equal to 6 to the 1. 3x is equal to 1, which means that x is 1/3. The answer here is 1/3. For number 5, I've got to rewrite in exponential form. Base 4 to the y is equal to x. Same thing for number 6. We're going to write this as y to the 7 is equal to x. Going backwards for number 7, this is going to be log base 8 of a is equal to negative 17. And the same thing for number 8. Log base 5 of 27 is equal to v. For our second set of problems, we're looking at log properties. We've got to expand or condense. The language here is a little bit messed up, so anytime that you see things that are all spread out, we've got to condense them. Things that are close together, we've got to expand them. So this first one, for example, is going to be condensing. First thing we do is deal with the powers that come from the dividing and the multiplying. And I would rewrite this as log base 9 of 7 to the 4th plus log base 9 of 11 to the 1/3 plus log base 9 of 2 to the 1/3. Next up, because I'm adding these logs, the same thing as multiplying on the inside. So I could rewrite this as log base 9 of 7 to the 4th times 11 to the 1/3 times 2 to the 1/3. You could also have written this as the cube root of 11 and the cube root of 2 instead of to the 1/3 power. For number 10, similarly, I'm going to deal with those powers first. And we're going to have log base 5 of 11 to the 20th. We're going to have plus log base 5 of 2 to the 20th and minus log base 5 3 to the 4th. I'm going to combine those. The multiplying comes from the adding. Dividing comes from the subtraction. I'm going to build one log, base 5. And the positives are going to go on top, so it's 11 to the 20th, 2 to the 20th. And on the bottom, I'm going to put my division part, so that's my negative. So that's 3 to the 4th. And I'm done. It's okay if you don't simplify these in terms of trying to write like 3 to the 4th equals 81. You don't have to do that out. For number 11, this is going to be expanding. The first two were condensing. Again, the instructions got a little bit messed up in doing this. I'm going to deal with that exponent on the outside first. First thing I might do is put that on each of the inside ones. That might be the easiest way. So we get log base 2 of x to the 20th over y to the 5th. And I can rewrite that as log base 2 of x to the 20th minus log base 2 of y to the 5th, which I can bring these powers down in front, so I can write that as 20 log base 2 of x minus 5 log base 2 of y. For number 12, similarly, I can deal with that stuff on the inside with that power first. So we end up with the natural log of x to the 30, y to the 6. I can split up the multiplication based on addition. We get the natural log of x to the 30 plus the natural log of y to the 6th. And finally bring those two powers down. And we get 30 natural log of x plus 6 natural log of y. And again, the instructions are all messed up, so these first two are expanding, and the next two are condensing. Since I don't have a power on the outside, what I might do is separate this by the multiplication pieces first. So we get log base 4 of x plus log base 4 of y plus log base 4 of z to the 5th. Only thing I can do is bring that 5 down front. So we get log base 4x plus log base 4 of y plus 5 log base 4 of z. For number 14, I'm going to deal with these powers first again, just to make my life easier. And we get log base 5 of a to the 4th, b to the 20th. Those are multiplied, so I'm going to add them together. We get log base 5 of a to the 4th plus log base 5, b to the 20th, and now bring those two powers down in front. 4 log base 5 of a plus 20 log base 5 of b. 15 and 16, we're back to condensing. And again, I'm sorry for the mix-up in terms of the instructions. I'm going to take the powers first and rewrite this as log base 8 of w to the 6th plus log base 8 of u to the 6th minus log base 8 of v to the 3rd. Next, I'm going to combine these into a single log expression. So log base 8 is going to be a fraction on the inside. The positive pieces go on top. That's w to the 6, u to the 6. The negative part goes on the bottom, v to the 3rd. At this point, we are done. I'm going to follow the same set of steps for number 16. I'm going to bring up any powers first, then I'm going to rewrite this as a single log expression. So it's log base 6 of 3 plus log base 6 of 11 squared plus log base 6 of 8 to the 5th power. All addition, so it's just going to be multiplication on the inside. Log base 6 of 3 times 11 squared times 8 to the 5th. And we're done. Next up, we're going to be solving some equations with logarithms. This did not go particularly well on the last spiral, so we're going to look at each of these types of problems. I'll do each problem instead of only doing half of them to make sure that we hit all the types of problems. You're probably going to see one like each classification problem in this document. Okay, first up, these are exponentials that do not have any logs in them, but require us to solve them with logarithms. In general, the first thing I want to do is to get that exponential piece by itself. To do that, first thing I need to do is add 5 to both sides. And then I'm going to divide by -7. But first we're going to rewrite this as -7 multiplied by 14 to the 7 minus p is equal to 39. We're going to divide both sides by, wow, I totally can't. This should be -29. Oof. Divide both sides by -7. And we get 14, and we'll try to rewrite this so it's a little bit easier to see, to the 7 minus p is equal to -29 over -7, which is 29 over 7. To keep going, I need to convert this to log form. So it's going to be log base 14 of 29 over 7 is equal to 7 minus p. To get the p by itself, I'm going to subtract 7 from both sides and multiply the entire equation by -1. And in doing so, you get p is equal to negative log base 14 of 29 over 7. And if I subtracted 7 times -1, that'd be plus 7. That's your final answer. For number 18, similarly, I'm going to get that exponential piece by itself first. To do that, I'm going to minus 4 to both sides. So we get 8 times 5 to the negative 7k minus 3 is equal to 59. If I divide by 8, we get 5 to the negative 7k minus 3 is equal to 59 over 8. Actually, I'll zoom in so I have a little more room. Okay, I'm going to convert this to log form at this time. So we're looking at log base 5 of 59 over 8, and that's equal to negative 7k minus 3. I'm going to add 3 to both sides. So we get log base 5 of 59 over 8 plus 3, and that took care of that. I've also got divide by -7. Divide the whole thing by -7, and I get k by itself. That's the answer I'm looking for. For number 19, now we have to deal with log. So since we have only one log, we're going to have to convert this to exponential at some point. Same thing. I'm going to get my log part by itself first. I cannot touch anything inside of that until after I convert to exponential. So to do that, we're going to divide both sides by 3. We get log base 7 of 6n is equal to -2. Let's convert to exponential. So we get 7 to the -2 is equal to 6n. And when we do that, we get 1 over 49 is equal to 6n. If I divide both sides by 6, we get 1 over 49 times 6 is equal to n. And 49 times 6 is going to be 240 plus 54. Something like 1 over 294. I reserve the right to be wrong on that one. And if I were to plug that back in, we should get to something that makes some sense with this. Same thing for number 20. We can get the log part by itself. Divide by -9, divide by -9. So we get log base 3 of -5k is equal to -2. Let's convert this to an exponential. 3 to the -2 is equal to -5k. That means 1 over 9 is equal to -5k. If I divide both sides by -5, we get 1 over -45 is equal to k. For number 21, this time we've got a log on both sides and nothing else. We call this the one-to-one log property. And if there are any ones that you don't have an issue with, these should be those ones. Because if you have a log on both sides that has the same value, or has the same log base, and that means that the insides have to be the same also. So 3x plus 5 is equal to 5x minus 1. If I add 1 to both sides, subtract 3x to both sides, and we get 2x is equal to 6. That means that x is equal to 3. If I plug that back in, we get log base 17 of 14 equals log base 17 of 14. And it works. Number 22, the same thing. We've got one log of base 10 on both sides and nothing else. -3x plus 9 is equal to -4x plus 5. If I add 4x to both sides minus 9 to both sides, we get 4x minus 3x is 1x, and negative 4 on the other side. And if I were to plug that back in, we get log of 21 is equal to log of 25? Nope, it's 21 because 4 times 4 is not 5 and never has been. So if you plug it in, those numbers still work. You are in good shape. For number 23, we've got to do some combining using log properties. And that's going to happen on the left side. Here I've got 2 logs on the same side, and 1 on the second side. I'm going to start by condensing. That's going to be the natural log of x times x is x squared, and x times 25 is 25x. And that's going to be equal to the natural log of 54. Now I'm going to use my 1-to-1 part. X squared plus 25x is equal to 54. I'm going to bring 54 to the other side. We get x squared plus 25x minus 54 is equal to 0. That factors into x plus 27 and x minus 2. Which means that x is equal to 27 and negative 27, and x is equal to 2. When I plug these values in, the natural log of negative 27 plus the natural log of negative 2 is equal to the natural log of 54. Here's the issue. You cannot take the log of a negative number. That means that this solution is called extraneous. It doesn't work when you try to plug it back in. For the other one, we get the natural log of 2 plus the natural log of 27 is equal to the natural log of 54. You can combine these. 2 times 7 is 54, and you get the same thing on both sides. That answer is good to go. Number 24, we're doing the same type of thing. I'm going to try to combine my 2 things on the left first and see what happens. So we get log base 4, and if I'm condensing these, we're going to have this, and that's a plus, and that guy, so we're going to multiply those. 8x minus 8 is equal to 4. Okay, at this point, it might be a good idea to convert this to an exponential. So 4 to the 4th power is equal to 8x minus 8. 4 to the 4th is going to be 256. 8x minus 8. If I add 8 to both sides, we get 264 is equal to 8x. If I divide both sides by by 8, this should come out to a really nice number. 256 divided by 8 would be 32. This should end up being 33. And if we add in this to the equation, we get log base 4 of 32, log base 4 of 8, and when you were to combine those, you get what you're looking for. Finally, we're dealing with log graphs. We're going to graph these the way we've been doing this in class, and I'd like to spend a little bit of time going through those once again. First things first is I want to make the inverse version of this, which is going to be x is equal to log base 4, y minus 1 plus 5. I'm going to minus 5. I'm going to add 5 to both sides. That's where that plus came from. So it was log base 4 of y minus 1. That means that 4 to the x plus 5 is equal to y minus 1. If I add 1 to both sides, we get y is equal to 4 to the x plus 5 plus 1. From here, I'm going to make a table. This is for my original function. And I'm going to plug in numbers that make my exponent -1, 0, and 1, just to give myself a nice range of the graph. The number that would make this -1 would be -6. And if I plug that in, we get 1/4 plus 1 is going to be 1.25. If I plug in -5, we get 4 to the 0 is 1, plus 1 is 2. And if I plug in a number that makes this 1, that would be -4. 4 plus 1 is 5. So I'm going to add these points in, so that's -5 and 2. -4 and 5. And -6 and 1.25. You don't actually have to graph this part. This is just so that we can see what our exponential version looks like. The last thing that we need is to worry about my asymptote. And here we get a horizontal asymptote of y is equal to 1, which makes sense based on that graph. Okay. In green, I'm going to talk about the log part. So this is the exponential version. This is the inverse. For the log graph, we're going to use the same points, but we're going to flip them around. 1.25 comma -6. So that's going to be like that. We're going to have -5 comma 2 becomes 2 comma -5. And -4 comma 5 becomes 5 comma -4. My horizontal asymptote y equals 1 also becomes x equals 1 for a vertical asymptote. And our graph should look something like this. I would like you to notice that these are reflections from my second quadrant to my fourth quadrant. Up next, we've got log base 4 of x plus 2 minus 2. I'm going to do the same thing. I'm going to convert this to exponential in order to make some sense of what's going on here. When I do that, I get y is equal to 4 to the x plus 2, and then it's going to be minus 2. Okay, I'm going to build my table. My points are going to make me give you values of -1, 0, and 1, again, just to make my life a little bit easier. The value that gives us -1 is going to be -3, and then -2, and then -1. When I plug those in, -3 gives me -1. We get -1.75. When I plug in -2, 4 to the 0 is 1, minus 2 is going to be -1. And finally, 4 to the first, which is what happens if you plug in -1, is 4 minus 2 is 2. At this time, I'm not going to graph my exponential version. I would like to note that my horizontal asymptote is y equals -2. Let's go straight to our log version. Okay, my log table is going to be -1.75 comma -3, -1, -2, and 2, -1. And my vertical asymptote is going to be x equals -2. Then we get -1, -2, and 2, -1. The graph should look something like this. Doing this again for 27. Again, we're going to convert this to exponential. That means we can get the log part by itself, convert to exponential, and rewrite this in terms of the exponential of base 5. What that's going to turn into is y is equal to 5 to the x plus 4, and then minus 4. It's kind of coincidental that we have the same plus 4 minus 4. That's coming because of the original equation, not because that's how this works every time. Although it's going to look pretty similar on 28 as well. I'll do that one all the way out so we can make sure we see what's going on there. I'm going to build my table. And again, it's really nice if I choose numbers that get the exponent equal to a -1, get the exponent equal to 0, and get the exponent equal to 1. To get -1, we need -5, because -5 plus 4 is 1. To get 0, it's going to be -4. And to get 1, it's -3. This is just being a little bit careful with choosing points. This is not required, but this is a very helpful thing to do in terms of getting to an answer without too much in terms of decimals. Okay, plugging in -5. 5 to the -1 is 0.2. 0.2 minus 4 is -3.8. Plugging in -4, 5 to the 0 is 1, minus 4 is 3. And plugging in -3, -3 plus 4 is 1, 5 minus 4 is 1. And then finally we've got a horizontal asymptote at y equals -4. When I turn this into the log form, all my points are going to switch. So we're going to have -3.8, -5. We're going to have 3, -4, and 1, -3. My horizontal asymptote at y equals -4 is going to become a vertical asymptote at x equals -4. Plugging these points in, we get 1, -3, 3, -4, and we're going to have -3.8, comma -5. One of these is not like the other. I'm going to check my math very quickly to make sure something didn't go wrong. For example, like if I plug in -4, 5 to, so 1 minus 4 was not 3, it's -3. This should actually be -3, -4, not 3, -4. So -3, -4, and that makes my equation look a lot more like it's supposed to in terms of points. Okay, and finally number 28, I said I would do this one all out. I will. Let's go with x is equal to log base 2, y minus 1 plus 1. I'm going to minus 1 to both sides. We get x minus 1 is equal to log base 2 of y minus 1. That means 2 to the x minus 1 is equal to y minus 1, and if I add 1 to both sides, we get y is equal to 2 to the x minus 1, and then plus 1. So it's just kind of coincidental based on using those points that this is coming up like this way 3 times in a row. I'm going to make my table, x and y. Again, I'm choosing points that make my exponent -1, 0, and 1. In this case, that would be 0, that would be 1 and 2. If I plug these in, 2 to the -1 is 0.5, plus 1 is 1.5. 2 to the 0 is 1, plus 1 is 2. And 2 to the 1 is 2, plus 1 is 3. Okay? I've also got a horizontal asymptote at y equals 1. So then when I go to do the log version of this, we're going to have points of 1.5 and 0, 2 and 1, 3 and 2, and a vertical asymptote at x equals 1. So we get 2, 1, 1.5, 0, and 3, 2. And if I graph this thing, it's going to look something like this.